Hey everyone, so in this video we're going to look at lesson 13.7, which is about whole numbers and fractions. Our I can statement is I can use representations to find fraction names for whole numbers. So basically just writing whole numbers like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on as fractions, because we can write whole numbers as fractions, and we're going to learn how to do that in this lesson. So our solve and share says, Jamie ate 6 pieces of apple pie during the week. Each piece was 1/6 of the whole pie. How much of the pie did Jamie eat? How much pie is left over? Solve this problem any way you choose. Explain how you decided. So by now you should have hopefully all of completed this packet. So this should just be a time for you to check your work if you weren't able to attend the Zoom meetings where we went over this. So there are 6 boxes here in the model that they give us. And before I go into drawing, I'm just going to read the speech bubble that says, use reasoning. Think about the size of each piece and the size of the whole pie. Show your work. So here it says he ate 6 pieces of apple pie during the week. Each piece was 1/6 of the whole pie. So basically, this drawing, this model right here, this rectangle, with the smaller rectangles inside of it, represents the pie. Well, why isn't it a circle? Because they chose not to make it a circle for this example. Each of these boxes represents the fraction 1/6. So I'm not going to write in each one. I'm just going to write it in this first one, but each box is represented by 1/6. And now I know that he ate 6 pieces of apple pie. So he ate 1 piece, 2 pieces, 3 pieces, 4, 5, and 6. So he ate all 6 pieces of the pie because, again, each is represented by 1/6, and he ate 6 pieces overall. So how much pie is left over? No pie is left over, so I could just say 0 pieces. And again, I'll put that S, sorry guys. But again, we have to look at the numbers that they give us, which is that he ate 6 pieces. There are 6 boxes right here. Each box represents 1 piece, and each piece is represented by the fraction 1/6. And the question that they ask is, how much pie is left over, which is 0 pieces. And they also ask, how much of the pie did Jamie eat? Jamie ate the entire pie. So for construct arguments, it says Jamie cuts another pie into smaller pieces. Each piece of the pie is 1/8 of the whole. Jamie gives away 8 pieces. Does Jamie have any pie left over? Explain how you know. 1/8. So it's literally the same problem as up above, except instead of him eating all the pie for himself, he's giving it away to people. So each piece is represented by 1/8. So each of these boxes up here, if we were to do it, would have 1/8, and there would be 8 full boxes. And he gave away all 8 of the pieces because it says he gives away 8 pieces. Does he have any pie left over? No. I know he has no pie left over because there are 8 pieces right here, the 1/8. There are 8 pieces to make up the whole pie, and he gave away 8 pieces. So no, he does not have anything left over. Again, for this, since I did go over this entire lesson in Zoom, even though I know all of you weren't able to attend, this video is hopefully going to go by kind of quickly. And I'm just going to be saying a lot of stuff. So if you need to pause at any point or rewind, just please do that. I am going to clear the whole screen now. And we're going to move on to the next page. For this, our essential question is, how can you use fraction names to represent whole numbers? So again, this is us going into naming numbers such as 1, 2, 3, 4, 5, 6, etc., so forth and so on, as fractions. So we wouldn't say it necessarily as for this, for 1/1, it would literally be 1/1, but you're not going to say 1 once because that's not a thing. So here it says, what are some equivalent fraction names for 1, 2, and 3? and they say the number line shows 3 wholes. Each whole is divided into 1 equal part. So again, it's just a basic number line. There's nothing special about this one. It's just 0, 1, 2, and 3. 1 whole divided into 1 equal part can be written as 1 over 1. 2 wholes each divided into 1 equal part can be written as 2 over 1. And 3 wholes divided into 1 equal part can be written as 3 over 1. So literally, the number 1, to make it stay as the number 1, you put a 1 on the bottom. 1's the denominator. 2, to keep it as the number 2, 1's the denominator. For the 3, 1's the denominator. So when we want to write just basic whole numbers as fractions, literally throw a 1 on the bottom as the denominator, and that's it. And whatever whole number you're naming is the numerator. Here it says you can find other equivalent fraction names for whole numbers. So this is when we get into becoming equivalent fractions, not just fractions that are equal or that name whole numbers. So here, 1 can be written as 1 over 1, 2 over 2, 4 over 4. Because remember, any fraction where the numerator and the denominator match, they equal the number 1. And then for the number 2, it says 2 over 1, 4 halves, and 8 fourths. So for the number 2, what I want you to pay attention to is, for example, when they give us 4 over 2, 4 over 2. 4 over 2 is equal to 2. 4 divided by 2 is 2. Take the top number, divide it by the bottom number, and you get what your whole number is for that fraction. And this only works if the numerator, number on top, is bigger. So again, they give us 8 fourths. Sorry, my mouse pad is a little messed up. So 8 fourths, 8 divided by 4 is 2. Again, it works for the 3's as well. You can try it and see if you're able to figure it out by solving it by dividing. The bottom part down here says, what equivalent fraction names can you write for 4 using denominators of 1, 2, or 4? So we're going to write all 3 of them. I'm just going to erase this stuff on the side right here. Mostly erase it. So for our denominators are going to be 1, 2, and 4. So to write the number 4, again, to leave it as a whole number 4, 4 over 1. That would equal the number 4, because all of these equal 4. Think about it. What divided by 2 is 4? 8. So 8 halves is equal to 4. And then what divided by 4 is 4? 16. So again, 16 divided by 4 is 4. And notice all of my numerators in this are all larger, so I can use my dividing trick to solve them. And I could also draw multiple number lines if I really wanted to, and to see where they line up. But that will take you longer, and I just think trying to have this little division trick under your belt will help you with your division, and it'll help you with equivalent fractions. Okay, I am going to clear the screen for this page as well, so please pause it if you need to now. Okay, and then our last page that we're looking at, they give us another example on top, and they're just saying that another way to write 2 is 12/6, because they have their 2 holes up here, 1 and then 2, and they line up with the 6th fraction strip. So you can also use paper fraction strips or digital fraction strips to find equivalent fractions to see which ones match up with one another, even when you're doing it for whole numbers. I know the website that I have provided only you can only do 2 whole numbers in the box. That's all that will fit, or 2 1 strips. So if you want to do more equivalent fractions with fraction strips, you can either try and find a different website, or you can just use the paper version to find your equivalent fractions using the fraction strips. Down here, it says, explain how you know that 4 over 1 equals 4. So for this, I'm going to read what the book answer says exactly, and then I will explain it in simpler terms. Because again, we always know that the book answers are always like really long. So 4/1 means 4 wholes. So 4/1 is another name for 4. 4/1 and 4 are at the same point on the number line. Okay, so how do I know that 4/1 equals 4? Because I know when the denominator is a 1, that the top number represents the whole number. So whether it's a 2 on top or a 3 on top as my numerator, if there's a 1 on the bottom, if I have 1 as my denominator, I know that the top number, the numerator, represents the whole number. I can also say that something like kind of going along with what the book said, I know that 4/1 equals 4 because they are at the same point on the number line. Or if I were to draw number lines, I would see that 4/1 and 4 meet at the same point. So you can go back for those explanations if you want to, pick which one you like, and use that one. And if you use something that's completely different, I'll just check it when I'm doing your work. You can let me know if you think that maybe you really weren't sure about this one, and then I can definitely make sure to pay attention to that when I'm grading your work. So for 2 and 3, where you have to just fill in the blanks. So for number 2, we have to complete the number line. So again, basic counting when we're filling in these blanks. They give us a 2. What comes before 2? 1. After 2, 3, and then 4. They give us the 5, and then they give us the 6. Down here, we have a lot more to fill in, but that's okay. What comes before 3? 2, and then 1. And then after 3, it's just filling in. There's nothing like special about this. We don't have to do it a certain way. It's just filling in numbers in order. They do give us this 8 right here though, so we want to make sure the next one we draw is a 9, and then 10, 11, and 12. So that's all we have to do is complete the number line for this. We don't have to do anything else. We don't have to name equivalent fractions. If you wanted to, just find out the fractions that meet and the ones that line up with each other, and those are some equivalent fractions for you. For number 3, it says look at the number line, write 2 equivalent fractions for each whole number. So we have to find one with the numerator of 3 that is equal to the number 1. So I know that 3/3 equals the whole number 1, and I know 6/6 equals the whole number 1. How do I know this? The 6 up here, or whatever you would want to say, well, I see a 6 and it matches up with a 2. No, it's just, remember, numerator and denominator match, it equals the number 1. That's it. It's one whole. And then for to equal the number 2, we have 6/3 and we have 12/6. For this, they match up with the number 2 here. And also, if I were to do my division trick, 6 divided by 3 is 2, and 12 divided by 6 is 2 as well. 4 through 5, it says you can draw number lines to help if you need to. So if you did that, you can always submit those to me if you forgot to, if you want me to see them. But you don't have to submit number lines, and you didn't have to draw them for these as well. It just says you can draw them if it's helpful to you. I'm just going to go ahead and fill in the blanks. So 4 is equal to 8/2 and 4/1. 1 is equal to 4/4 and 1/1, or 4/4 and 1/1. 2 is equal to 6/3 and 2/1. And 5 is equal to 10/2 and 5/1. For the bottom part down here, it says for each pair of fractions, write the equivalent whole number. So our answers for these should just be whole numbers. It's one number, so like 1, 2, 3, 4, 5. 6/2 and 3/1. I know without even looking at the 6/2 that 3/1 tells me that my whole number for this is 3. 3/3, 6/6, matching numerators and denominators, that's equal to 1. 8/4, 6/2, 8 divided by 4 is 2, 6 divided by 3 is 2, my whole number is 2. 9/3, 12/4, 9 divided by 3 is 3, and also 12 divided by 4 is 3. And if you aren't, if you're a little rusty on your division facts, go back to your multiplication facts. 4 times what is 12? 3. 9 times what is 9? 3. So it can give you another way to fill it in, especially if you know that you're stronger in multiplication right as of right now than you are in division. But like I said, I encourage you to work on these equivalent fractions and solving them by using some division, because it helps you with equivalent fractions and just basic division overall. You are at the end of this video. If you did not attend the Zoom meeting and you are watching this right now, please let me know that you watched it, just so I can still keep track. And if you have any questions, let me know. Okay, bye guys.